Hi, I'm Jeff Ray, your host for Economic Outlook. Welcome to our show. We're back in the studio today for another great show. We hope you'll make plans to join us each week as we discuss the region's most important economic developments and initiatives with a panel of experts. A chip is a small piece of silicon that contains circuitry that allows it to perform a specific function. Chips are used in everything from phones and computers to cars and medical devices. But growing demand and a worldwide chip shortage in 2022 has slowed growth in many industries. We'll take a closer look at the chip shortage, talk about how it impacts you, and what's being done to stop it, coming up on Economic Outlook. We're back in the studio for a new season here in Economic Outlook, and today we believe we have a great show for you. The global chip shortage has slowed production in many industries like automotive and gaming and delayed the rollout of new technologies. Joining me today to talk more about semiconductors, chips, and the chip shortage is Derek Lake, Associate Director of ND Nano Science and Technology. Derek, welcome.
Thanks, Jeff. Great to be here.
Yeah, so we're glad to have you. So, so obviously the news has paid a lot of attention to semiconductors and chips and some of that. I'm not sure everybody knows a lot about that, so we thought we'd grab an expert today and pick your brain a little bit and help us understand that a little bit. Before we get into talking chips and semiconductors and such, so tell us a little bit about your background and tell us a little about ND Nano and what you do there.
Sure. So I spent about 15 years in the chemical and materials industry and working for global materials companies. And then about 3 years ago, I joined Notre Dame as Associate Director for Notre Dame Nanoscience and Technology. And so we're a center at campus that brings faculty together around nanoscale research. And we provide and support faculty to help bring them together to collaborate and also support their research ventures there at the university, in which semiconductors is part of that.
Great. It's been exciting to watch the evolution of Notre Dame in recent years, in particular in the research space, in terms of to watch ND Nano come on board and then the other space. So kind of why we tapped you today then, just because you mentioned semiconductors and chips and all this. So I may use a few of those interchangeably. I apologize for that. So for folks who aren't familiar with some of these terms, talk to us a little bit about what a semiconductor or a chip is and why it's important to them.
Sure. So when we talk about semiconductors, it's a material just like the name says. It's partially semiconductive, so it falls somewhere between what like a metal that would be conductive and an insulator, which is not conductive. And so these wafers are made out of silicon, and so similar to what you might think of sand, and it's pure quartz material that they take and make into these silicon wafers. And then those have essentially nanometer scale wires and transistors and other features laid on top of those. And then those are cut out and placed into what we would think as the chips. And so then those are constructed into the housing and the packaging, which is very important, how all that fits together. On those scale, you've got those parts all that close together, and they're generating heat, so forth, and how they're put together. That small scale is very important. And so those all go together. And so then if you were to open up your phone or your computer or your television, really anything today, you're going to see these chips in, and they're really pervasive across the ecosystem.
Great. So we hear a lot about it today, but obviously as technologies evolved over time, they've been around for a while. So how long have we been dealing with semiconductors, would you say?
Yeah, so it's good. They been around for
probably as electronics were starting to develop. And
yeah, exactly.
In the 20th century, early 20th century, maybe.
Yeah, so going back to 60s, 70s time frame, those, and so, but probably more what we think about is our modern microelectronics, as it continues to scale down. So you've had these advances in size and scale, which have enabled the smaller devices like the phone, for example. If we think back to what was in place with like some of the computers at like NASA when there was the moon missions and things, they took up rooms, and now we can do that with something that sits on a table.
Sure. So when I think about like my phone, just using an example, are there many chips in there? Is it one that helps power it? Help us give a feel for, or my car or whatever. My guess is it takes a whole series of these to sort of affect the work that's happening there?
Yeah, so the chips will have different functions with them, and so some, of course, are higher end. So as you get new phones that come out, they're going to have higher end chips in them that control the phone. But you also may have a little bit, I'd say, kind of lower end that are providing power, or think about in your car too. While those are going to be a little bit lower end chips, maybe with a controller for your seat or for your automotive or your motorized mirror on the side, or even some can help and control some of the sensors in the engine. But what's important is that they all have different functions and also different environments they have to be in. The chip that will go into your car around the engine is going to have a lot more, be able to sustain higher heats, for example, than maybe what's in your phone, and have different functions.
Sure. So, and fascinating conversation. I appreciate it. I'm learning a lot already on this. So as we've been watching the news and we hear whether it's Apple saying we got to slow down the release of the next iPhone, or automakers saying we got to slow production of our cars because we have this shortage. Talk to us a little bit about the shortage and why we have a chip shortage and how that's impacting the economy a little bit.
Yeah, so it's really interesting how this all came up, and so number one to say is that the semiconductor supply chain is pretty complex. It involves multiple steps around the globe, and so number one, anytime you have a complex supply chain like that, something can go wrong in it and go down. So the one thing to understand is there's a couple different types of producers for chips. Ones that are really design them, so they'll kind of draw them up and make the designs, but they don't actually have facilities that make them. And then, so what we think of as being the producers, really, that they may design their own, but they also will produce for other people. And so in the U.S., we're making around 10% of the chips today globally. And East Asia is accounting really for closer to 70% of those, with Taiwan around 54% of them. And so what happened is when you've got this extended supply chain, and it requires these complex environments to make them, and so things can happen. So number one, when the pandemic started, the automotive industry, for example, decided that, hey, there's probably a recession coming and people aren't going to be going anywhere, staying home, and so they delayed or canceled orders for their chips. However, what we all know that happened as a result of that is we end up staying in and buying personal electronics, gaming, things to help us work from home, and so then the demand for personal electronics went up. So these chip manufacturers, what they did is they switched over their production from the automotive chips to some of these personal devices and phones and that sort of thing. And it takes a long time to switch over production. And so when the automotive manufacturers came back and said, hey, we really need to get our chips now so we can continue production, it wasn't easy as just stopping what they were making and going back to it. So it's either the case that they could sell those chips into the personal computing or phone and gaming, that sort of those devices, or they had to completely retool their manufacturing facility to go from automotive chips to these other types of chips.
Great. So I'm continuing my conversation with Derek Lake, the Associate Director of Notre Dame Nanoscience and Technology. Derek, we're going to take a quick break. We're going to go out into the field. George Lepignotis, my co-host, is out to add to the story. George, let me toss it to you.
Thanks, Jeff. Speaking of microchips and things that make electronics work nowadays, I have the distinct privilege to be on campus at the University of Notre Dame. I'm joined today by Professor Patrick Fay. Professor, thank you for being with us.
Oh, it's my pleasure.
Professor, right behind us is what I'll call your baby. It's got a very explicit name, but it's a nanotech lab.
Yes, that's exactly right.
Can you tell our viewers who are looking at it right now what exactly this facility does?
Sure. This facility, we use it for research in advanced electronics, in developing devices for, say, lab-on-a-chip medical testing, as well as for micro-electromechanical systems. But it's really for advanced prototyping and research. We also use it, some companies use it for developing their prototypes and commercialization efforts.
Before we went on air, I asked you, you said you're a professor of electrical engineering, and I said, well, is that Is that all about nanotechnology and microchips? And you said, well, pretty much every electronic nowadays is based on nanotechnology. That is the case. Everything is truly in the electronics world getting smaller.
That's absolutely the case. Nanotechnology underpins all of electronics these days.
Other than the convenience of carrying, mobility, what is the benefit of shrinking something?
Yeah, so the efficiency improves. So for example, in a mobile device, that means how much computation you can do or how long it will function on a given battery life. It also improves the frequency response, which opens up higher frequencies for communications, as well as just making it overall more power efficient and more capable.
Yeah. Our show is about the region's economy here in Michiana, but this lab actually is, as we talked about, one of the most impressive and modern labs in any educational environment around the country. You're focused on these nanotechnologies. How is it that helps students first off, but then how does it make that transition into the commercial world?
Sure. So with regard to students, we use this to teach courses. Students who come through this will have made test circuits, as well as, actually they make an integrated circuit that can play the fight song in a very Notre Dame sort of thing. But our more advanced students do research. They develop new transistor technologies, new electronic devices that have never been made anywhere else before, and we build them here, test them, and really validate how well they work and how they compare to the state of the art. That all helps to develop a workforce, and then they go off to work at places like Intel and Micron and other advanced semiconductor houses.
Yeah. And in addition to training students, teaching students, you also have that relationship with private users that come for this facility.
Yes, that's right. There's been a number of companies that have used our facility to either develop their prototypes and then they've gone off and commercialized it, or they use us as sort of an advanced R&D arm where they can come in and prototype a few things, see how well it works, and really use us as a way of getting ahead of their R&D curve.
Right. You know, before we went on air, I was thinking about what a major role universities across the country have played in engineering advancements, from the atom bomb. I see there on your board that one of the first wireless messages was actually sent from Notre Dame to St. Mary's.
Yes.
And today, wireless messaging is a massive part of our world. What is it about the educational institution that makes it conducive to this type of research?
We have faculty with interests, specializations that cover the span from people who are like me, semiconductor people, very low level in terms of their interest in semiconductors and in transistors, all the way up to people who think about protocols and big system sorts of issues. And so by integrating over this really large span from semiconductor devices all the way through systems, we have people we can interact with and understand how the technologies will all fit together to make a complicated system like a wireless communication system.
Yeah, that's awesome. Before we went on air, you told me a little bit about your work here on the 5G cellular network, the 6G network that we've all maybe heard a little bit about but aren't sure. What is the engineering milestone? What is it that you think really is that next advancement? Is it continuing to make things smaller, or is it more about being efficient with the energy it takes to make the device work?
Yes, so there's all of the above,
Yeah.
but of course power efficiency is very important and performance is very important. And what we see now is that silicon is becoming difficult to scale any further, and so what we're doing is we're looking at additional materials that can provide performance beyond what's possible with silicon. In particular, I'm working on gallium nitride that is especially power efficient and especially high performance in high frequency applications. So this is exactly what 6G needs in order to really work the way we really all want it to.
Yeah. Well, that's such an interesting part of the engineering challenge that we live through on a day-to-day basis. And they're somewhat miraculous, these devices that we have in our hands, and the power that we wield, even looking back only 20, 30 years ago. Thank you for being with us today, Professor. I appreciate the tour. I appreciate your time. I know you're busy, but really, it's been a great day. Jeff, back to you in the studio, where I'm sure you've got a lot more to talk about, not only about microchips and the economics of it, but also just about where our economy is going as it becomes smaller and more digital.
George, thanks. Appreciate the inside look at what's going on out there on campus. We're back with Derek Lake, the Associate Director of ND Nanoscience and Technology. Derek, thanks for continuing our conversation. Me and our audience, I think, are learning a lot already. So we're continuing this conversation about chips. We talked briefly about production of chips, kind of the shortage of it. We talked a little bit about how much of it's produced outside the U.S. The United States, though, is making a big push to bring some of that production back to the U.S. Can you talk a little bit about what the U.S. is doing to try to help produce more chips here?
Yeah. So currently the U.S. still is top in designing chips. So from the technology standpoint, as I mentioned, it's only about 10% of the global manufacturing capacity. So the companies are looking to bring back that manufacturing capacity to the U.S. and for a few reasons. One, of course, is about kind of commercial supply security. You know, we experienced that with the pandemic, and so being able to differentiate what the suppliers are. And then you have also some of the issues with geopolitical issues with being in East Asia and potential issues there. A pandemic occurs again and could shut things down, and so then you have problems. And it's also important from a national security issue, making sure that we can produce the chips that we need to go into national security, whether it's in missiles or defense radar, you know, whatever it may be, but then also be able to trust those electronics that go in there. So are we able to get those from trusted sources? And so companies are already looking at where they can bring manufacturing back. So whether it's expanding current facilities or also building new ones here in the U.S.
Great. So they're getting lots of attention. I think people are anxious for them. A very high-tech manufacturing. So Indiana also has this on their radar. I don't know where chips are ultimately get produced. Indiana feels like they want to play in this space. Can you talk a little bit about just sort of the state and the state's approach, or some of the things the state's trying to do?
Yeah. So a couple things to mention there is, Intel has already made an announcement in Ohio that they're going to put a chip foundry there, and that'll be a large one, and they're estimating there's going to be around a workforce of 3,000 people once that gets up and running. And then there will be a smaller company, but still a sizable one, is SkyWater Technology, who's talked about putting a foundry in the state as well, and they're smaller and a little bit different type of manufacturer than Intel, so they're already looking there. But the state has formed a task force. The IEDC has put a task force together that is looking at ways to attract companies to the state, looking at what the state can do overall, and that includes members of academia, industry, and other kind of think tanks within the state to help attract those. And so they're looking at that. And then also from an academic standpoint, we are working together between universities on how we can collaborate on research in this area.
Great. No, it sounds good. So let's talk a little bit more, because you touched at the beginning on ND Nanoscience and Technology and kind of your role there. Sort of what's happening in semiconductor kind of falls under your space. Talk about some things Notre Dame maybe is doing to try to position themselves in this space as well.
Yeah, so we have a long history of working in semiconductors. For example, we've had for the past 15 years centers which bring together universities from across the U.S. that have been funded by the Semiconductor Research Corporation, and in particular the ones that we've had here at the university have been around devices, and so looking, for example, how do we continue to reduce the power and operate these computers, so these chips and semiconductors that reduce power, or how do we integrate more features into these devices and semiconductors. And then also we've got research around the next generation of communications, which are going to be very important with semiconductors. I mean, that's going to play a role as we advance, go to 6G and other advanced wireless communications. We've got research going on in that area. And then I think something we were talking about before is having these facilities and having the expertise on campus that we can continue to grow in this area. So looking at new types of semiconductors, looking at how we can continue to shrink that down and continue to essentially build on Moore's Law from that way.
Right. You know, it's interesting to think about today's semiconductor is really different than probably one from a year ago or 5 years ago or 10 years ago, and the technology is evolving, so it's been interesting to hear more and more. So talk for a second about just maybe the student, like is this the engineering students or science or whatever? Talk to us a little bit about obviously the professors, you know, I think kind of on the research side, but the student opportunity to just tell us who's interested in this space.
That's a really good question, because this is going to be vital to bringing the semiconductor industry back to the U.S. and growing it. So really not bringing it back, but really looking at how to grow it. And so we're going to need a lot of workers in this area. And so the Semiconductor Association has estimated they're going to need, if this $50 billion, which is in the CHIPS Act, is invested, around 42,000 workers over the next 5 years in this area. And that could lead to another 280,000 jobs even related to this industry, is what they're estimating. So these are engineers in electrical engineering, computer science engineering, even chemical engineering. But I would say not only is it, but it's at all levels. So we're talking, you know, it could be associate's degrees, bachelor's degrees, master's, PhD, or certificates. So there's going to be a wide range of new employees needed, and training, and just a lot of opportunity for employees to come into this space.
Yeah, no, it's interesting because especially young people, I think, are thinking about those new opportunities. Obviously, communities, when they hear about those job opportunities, these are pretty good jobs for a community if they can attract. I know the Ohio project had garnered a lot of interest from different states in terms of trying to attract that. So.
Yeah, and one of the things they mentioned, Intel mentioned there, is they put it there because they have access to not only talent in Ohio, but a talent in the region, which includes Indiana.
Yeah, sure. So talk a little bit. You mentioned in this space that the university works with other universities too. So obviously there's a, I don't know, is there a co-opetition here? They're all you're competing on some levels with them. You're cooperating on others. Talk about just Notre Dame and how they team up or work with other institutions on things like this or other industries.
Yeah, so we work together to kind of build on the strengths between the universities and to come out with something larger and a larger center or a larger type of research effort. And so this can be from a technical standpoint, you know, as you mentioned, trying to develop the next generation or advance semiconductor research. It can also be around workforce development, so looking at how to change and improve curricula in here so that as we're growing the next force, the next generation workforce, and people are transitioning, making sure they have the right education and classes in there. And so I'd say both those levels. So that include universities within Indiana like Purdue, but also we have research centers at the university where we're working across the country with multiple institutions.
And at the same time, are you working with private sector as well too? I mean, is there a little bit of are the chip makers doing a little bit and the university's doing a little bit? Are they doing that together or sort of separate? Or?
Yeah, so there's research that's funded by industry there at the university, and then also other collaborations to help get students, for example, into internships and get them into the industry as well.
So how about let's talk in our last 2 minutes or so about the student interest. So obviously, as we're watching all this, technology is growing. There seems to be a greater need for all of those different studies that you talked about, whether it's computers or engineering or different things. What's the interest level? I mean, is this something that there's great interest in this, and does this help Notre Dame attract students here because of the research that's happening there?
Yeah, so I think one of the important things to think about here is that this is going to require probably a larger effort to educate students, even down into high school and grade school about, for example, what a semiconductor is, why is it important to the economy, why is it important to me on an everyday level, and then help them understand how the science they're learning and eventually physics and math and things that they're learning can apply to this. So So it's important to continue to grow this. It's exciting. For example, talking about the CHIPS Act, this is like a once in a generation type of investment, and so it is exciting, these opportunities that are going to be coming for students and workforce.
Yeah, and you mentioned, and just back to CHIPS real quick, $50 billion, is that the number the federal government's talking about investing into?
That's
the
right.
CHIPS
So
Act?
that's going to be funds that they'll make available to help spur the construction of new fabs and expansion of facilities, and then they're also making around $24 billion in tax credits available as well.
Great, good. Well, he's Derek Lake. He's the Associate Director of ND Nanoscience and Technology. Derek, thank you so much for the conversation today. Really appreciate the insight and helping us learn a little bit more. Appreciate the work you're doing on campus, and we'll look forward to having you back for some additional conversation.
Thanks, Jeff. Glad to be here.
Great. That's it for our show today. Thank you for watching on WNIT or listening to our podcast. To watch this episode again or any of our past episodes, you can find Economic Outlook at WNIT.org or find our podcast on most major podcast platforms. Like us on Facebook, follow us on Twitter. Please join us next week as we continue to cover the region's most exciting and important topics that affect you. I'm Jeff Ray. I'll see you next week.
This WNIT local production has been made possible in part by viewers like you. Thank you.